Hello everyone. Today in this video, we will be discussing about MCP Server. So let's start with the basics. What exactly is an MCP Server? MCP stands for Model Context Protocol. It is an open standard designed to let AI models connect with external tools, data, and services. So think of an MCP server as a bridge. On one side, you have your AI model. On the other side, you have tools, resources, or prompts that model can use. The MCP server exposes these tools in a consistent way, and communication happens over a sample JSON RPC protocol. That means instead of building one-off integrations for every client, we now have a standardized interface. As you can see in the diagram, MCP server is in the middle. AI applications like chat interfaces, IDs connects to MCP server, and it provides access to all sorts of data sources and productivity tools. So in short, an MCP server is the key that unlocks external capabilities of AI, making it much more useful in real workflows. So why do we need an MCP server? The biggest reason is standardization. Without MCP, every AI tool needs its own custom integrations for each data source or service. That's a lot of duplicated work. With MCP, we have one protocol that all tools can follow. The second one is interoperability. Once you build an MCP server, any client that understands MCP, whether it's a chat interface, an IDE, or another AI app, can use it right away. The third one is reusability. You don't have to reinvent the wheel for every new project. Build your tools once in an MCP server and reuse them across multiple applications. The fourth one is MCP is extensible. You can keep adding new tools, prompts, or resources as your needs grow, and they will immediately available to all compatible clients. And finally, security and control. As a server owner, you can decide exactly what your AI assistant can access, whether that's a database, logs, any productivity tools. So in short, MCP server make AI integration easier, more secure, and for more scalable. Yeah, so in this video, we are going to put all this into action. First, we will be deploying a custom MCP server. Then we will connect it to Inspector UI. The MCP server will be capable of fetching the list of pods and getting the pod logs. And then we will analyze it using OpenAI. This is the high-level architecture or a high-level flow diagram for what we are doing today. We will be having MCP server deployed in Kubernetes in one of the namespaces. And then we have another namespace where we'll be adding some sample applications to generate logs. The MCP client will be accessing the MCP server and also OpenAI model. So now let's quickly jump into the demo. Let us start with the Python script, which we will be using for creating the MCP server. So at the top, we have three important things. The library imports basically for MCP, which will be used for tooling, and then Kubernetes to talk to cluster, and then OpenAI for analysis. Yeah. And here I create the server with fast MCP. So this is the name which the client will be seeing. Yeah. Then we have a tiny gate function which will be used to authenticate to the cluster. So in my case, I'll be using the local kubectl. Then moving down, we have the Open AI part where we have the Open API key being specified. So this will be used for the third tool for analysis. So for that, we may need Open API key. I'll come to this when we run the actual code. All right. And moving down, we have the three tools here: list pods, get pod logs, and codex analysis. So list pod will basically just list the pods in a namespace, and get pod logs will of course, describe the not describe give the port logs, and then we have final tool which is for analysis. For this we will be using OpenAI, and for this example we have given a sample model which I'll explain when we go to the actual Kubernetes deployment. Finally, MCP run. This will start an HTTP endpoint at /MCP on port 8000. So any MCP client can call those tools. That's it. Three functions, one endpoint, list pods, get pods, and analyze logs. This is our Docker file, which we will be using to create the image. We are using the Python base image. Then these are all the basic steps for copying the script and the requirement txt file. Here, and running the pip install init, exposing the port 8000, and finally running Python command. Yeah. Let's move on to the Kubernetes manifest. So in the Kubernetes manifest, we have a namespace, deployment, then we have service, ingress, service account, cluster role, and cluster role binding. So I am using Nginx Ingress here because I already have Nginx Ingress deployed in my machine. So yeah, I'm just making use of it. Then coming back to deployment, my deployment name will be my MCP server. So it will be deployed in the namespace MCP with replicas 2. If I scroll down, here we have a couple of environment variables being declared. So one is the coding model. This is optional. Okay. So we will be using a minimal model for doing analysis. I have also set resource limits and request, which is optional, but it's good to have it. But for a demo purpose, I would say we can ignore it. Yeah, it's always good to use resource request limit for deployment. Yeah, and we have the service created here, which will be listening on 8000. This is the ingress. Yeah, I already added the host entry. I'll show you that. Let me just quickly open terminal. Yeah, so I have the mcp.local here, which is pointing to localhost. And then coming to service account. So we will be creating a service account named mcp-sa, and we'll be giving complete access to the cluster. So that's why we have created cluster role and cluster role binding here, so that we can list pods, get logs from all the pods, whichever pods we need, whichever namespace we need in the cluster. Yeah, now let's deploy this. Okay, so we need to build the Docker image. For that, let me copy the image which I'm using here. Yeah, so Docker build -t. Oops, my bad. Okay. Yeah. So we are building the Docker image. That's now done. Now we will be deploying the MCP KTML, the actual Kubernetes manifest for deploying MCP server. kubectl apply -f mcp right? So if you can see here, namespace, deployment, service, ingress, service account, cluster role, and cluster role binding has been created. Now let me do a kubectl and get pods MCP. Oops. Okay, so it looks like there is some config error. Let me do kubectl describe. Okay, warning failed. Error secret OpenAI API key not found. Okay, got it. So let me go back to the manifest file. In the deployment section, we have a reference to secret, which is Open API key. So this one I haven't created yet. So for now, let me comment this one out, save it. We'll do apply again. Done. Now let me do kubectl get pods minus. Okay. Yeah. So the old pods has been terminated and new ones are up. Let me check the logs. Okay. It says the application is up. Now we will install MCP client, or I would say a debugging tool. Let me go to browser and search for MCP Inspector tool. Okay, right. So this can be run directly using npx command. So let me run this. Okay, so starting MCP Inspector. Oh, it's already up. Okay. Now what we have to do is, let me open a different terminal. I'll port forward the MCP server. For that kubectl, we'll use port forward command minus an MCP port forward. So service name is my MCP server. Right, running on 8000. Yeah, right. Now let's go back to the MCP inspector here. So we have localhost 8000. It will be listening on port 8000 and the endpoint is /MCP. Let me quickly connect this. Okay, now this is connected. If I go to tools here and do a list tool, we can see the three tools which we created using the MCP server or in the MCP server. So we have list pods, get pod logs, and then codex analysis pod. So let's first test these two tools. We'll go to list pods. For now, let me choose namespace. Okay, let me go back to terminal again. Okay, I don't want to lose this connection. Let me open different tab again. Oops, get ns. Okay, I'll do a list on this book info namespace and run. Right, so here we can see the list of pods in the namespace book info. Let me try a different, maybe Jenkins or Istio system. Yeah, I want to make sure that the service account which we created is having access to all the namespaces. Istio D, there's only one pod. Yeah, it looks good. Now let me go to next tool, which is get pod logs. For that, I'll use again the book info. And then if I go to book info, okay, let me do one thing. I'll type book info here in the namespace so that we'll get the list of pods. I'll copy this pod name from here. I'll go to get pod logs, paste the pod name here, then namespace is again book info. Container name is not mandatory. That's not that's how we have created the MCP server. Tail lines, okay, I'll make it 50. Run to. Okay, so we can see some bad request. So this is not the error from the client, but it's the error of the pod. Right. Let me choose a different namespace. Maybe this time Ingress, Nginx, or Istio system. We'll choose Istio system. Pods -n. So I'm just taking the name of the Istio pod, paste it over here, run. Okay, so we have the pod logs of Istio. So now we have tested tools list pods and get pod logs. Next is codex analysis. For this to work, we have to create an OpenAPI key that will be used to connect to the OpenAI model. So for that, if I go back to the deployment file, the portion of the code which we commented out, let me uncomment it. Yeah. Now we have to create a secret OpenAI-API key, and we have to feed the API key in it. Yeah, you can create the OpenAI API key from the portal. For that, you can visit Open API platform. Yeah. So if you don't have an account, just create one and start playing with this. So here we have the options to create API keys. So I have already created one. So let me run the command so that I'll create a secret. So this is my API key. I'll be deleting soon after this video is uploaded. So yeah, don't worry about that. Yeah, so the secret has been created. Now let us get the pods again. And yeah, we have to patch the deployment. Let me save this file and do an apply again. So if you see the deployment has been reconfigured, we'll get the pods again. And you can see the new pods are coming up, the olds are getting terminated. Yeah, the new ones are running now. Great, so 2 pods are up and running. Now let me go back to the inspector. I'll close this one, yeah. And I'll do list, okay, so before that, let me port forward it again. Okay, now in the inspector, I'll connect it. Yeah, it's connected. I'll list the tools. Here we have the codex analysis pod. Okay, now let's do an analysis on any of the pod. So for that, let me take booking for namespace and get pods minus. Okay, I'll take the pod details v1 pod. Let me copy it. Here we go. This is the question. Explain errors, warnings, and suggest concrete fixes. So this is something which is coming from the Python script which we wrote. Tail lines, I want to go to 200 lines. I'll just take it 60 or 50 lines. Yeah, and run it. Okay, based on the load which we are giving to the OpenAI, it will take some time for getting the analysis reports. That's why I made this 50 lines from 200. So let's see the error. Okay, this looks to be good. So here, if you see, we have the structured content. Let me copy both. We have unstructured content also. So let me copy the unstructured one and I'll keep it in a new file. Logs, log analysis, maybe. Yeah. Right. Let me paste it here. Okay, so it clearly says that log indicates a 400 bad request error due to missing container name when trying to interact with pod. The pod has multiple containers. Istio, yeah, that's true. So uh, this is one of the applications which I created in the previous tutorial for demonstrating the purpose of Istio. Yeah, of course, it's having Istio init details and other Istio proxy components. So you need to specify which container you want to interact with. Okay, right. So this states that in the inspector we haven't specified the container. So let me do one thing. I'll copy one of the container names. I'll take this one. This is the application. And if I go to inspector again, and here we have an option to add container. Oh no, so we don't have an option. So I need to update the script again to add container option also. So let's do one thing. I'll take a pod which is having only one container in it. Okay, right, demo logs. Okay, let me see if something is there. Get ns, get pods, nice. Okay, I have one sample application running here. Demo bin. Okay, let me go back to the code. I have a log app. Yeah. Again, this is a sample application which we can use to test the logs. So here I'm using a ready-made image. Let me just quickly go and deploy this. So we have the service and also the ingress being created. So it is logs app. Okay, let me go back and do kubectl apply -f logs app YAML. Okay, so it created deployment service and ingress. Let me do kubectl get pods -n and demo logs. Okay, it's running. So let me just do check the logs of this pod. Demo logs. Okay, great. So it is having some logs. I think I have already added it to the host entry for my previous testing. Let me see logs app.local. So it's already there. Now what we can do is I'll open the Postman. So in Postman, let's simply run logs app.local. We'll send some traffic. Yeah, looks like it's hitting the pod and we are getting 200 response. Now, this specific app is having other endpoints which will throw some errors. For example, we have an endpoint called /missing. So if I do this, I'm getting 404. Let's see if these errors are being logged. Yeah, that's great. So in the pod which we deployed now, we can see some good amount of logs. Now let's go back to the inspector and change the namespace to demo logs. Okay, we'll first do a list pods and demo logs. So we have two pods running. One is HTTP echo. That's the one which we created. It's just printing some random messages based on the endpoints we are calling. And this is another sample application which I deployed earlier. So just forgot about this. We'll take the echo application first. I'll copy the pod name here. We'll go to okay, get pod logs. Demo -logs. We'll keep it 50 lines. I don't want to have more lines now. Okay, so it is giving the output. Now let me go to codex analysis pod. This is the final tool which we have to test now. Demo -logs. Here's the pod name. I'll make it 60 or 80 lines. Then run it. Okay, this always takes some time based on the uh, lines of code or logs which we are giving for analysis. Yeah, so that's a success. Now let me copy this result and I'll paste it here. Okay, this is a structured one. I'll take the unstructured one so that we can read it easily. Here you go. So summary of logs. So the log is having 404 error. So the same thing which we observed in this specific endpoint when we try to hit slash missing endpoint, it says 404. Okay. Now let's say how this has been analyzed by the model. So the log shows get slash missing request returning a 404 status. So it is asking us to check. These are the health checks being done basically. There's a ping test being done by the application. Then, okay, let's focus on the issues identified. So the issue is 404 error. The endpoint slash missing does not exist in your application, leading a 404. That's a clear answer, yeah, that we all know. Then, so let's see what are the actionable fixes. So one is to verify the endpoint. Check if slash missing endpoint is intended to exist. If it should implement the route in your application, yeah, that's true. If it is not intended, ensure the clients are not making requests to this endpoint, yeah. Right, and then update documentation, implement error handlings. Consider adding a custom error page, okay, rather than 404. It's good to add a custom error page. Yeah, and these are some application routes which will help us to troubleshoot this. It's an example command. It's just doing kubectl exec. Then again, in application code perspective, if you're using JavaScript, we can use these frameworks needed, and then redeploy. That's it. We deployed a tiny MCP server on Docker desktops, Kubernetes, listed pods, pulled real logs, and sent them to an LLM for instance and actionable analysis. Then we kept it safe using RBAC, which is easy to extend. If this helped you, please try it yourself and share it with your friends. Thank you.